Hello everyone and welcome to another episode of Let's Code Duke Nukem, where we aim to recreate the original EGA action platformer, released in 1991. Last episode we drew all the borders to the screen, animated the background tiles and made the camera system more dynamic. This really made the game feel more solid, but it still leaves us with a lot of gaps inside of the level. In order to fill those gaps, this episode we will build in support for the decorative background elements the game has on offer. This will not fill all of the gaps that we can see, but that will require several episodes as most gaps represent more complex cases, such as enemies and items. First though, let us focus on implementing the font system in order to be able to display the score and the various text messages. Let's go. Okay, so let's start again by converting some graphics to a sprite sheet. So this is something that we've been doing 2 times before already, so this is going to be the 3rd time that we're doing this, so I'm just going to make a function that I can reuse again. So let's make a 2-sheet thing that takes in the name, or I guess we can just take in a list of buffered image tiles, and then we can just go ahead and create one single image, and then the width of this image will be tiles times 16. Let's take the width of the first tile, and let's get the height of that first tile. First dot width, first height. So all the tiles in the list will be the same size because they will be coming from the same file. So this is the width and this is the height and the type. Return the image, and then let's loop over each of them. Let's jump it on the image, draw image tiles, get I times width 0, null. Okay, let's make a static void main, and let's create a resource loader. And let's read font 1. Let's add all from font 2. This should be transparent. And I guess we need this extension as well, .dn1. And false. And then let's create that, convert that to a sheet. To sheet loader.toSheet. All these tiles. Oh, guess I'll need to just assign this list buffered image fonts equals the first font, and then we can just say fonts.add all the second font, and then sheet is the fonts. And I guess image.io.write sheet png font.png, new file. I always forget that one. All right, so now we have something we can reuse for future episodes, because there are still many files that we probably need to inspect. But let's take a look at the font. If it actually compiles. There we go. All right, so here we have the entire font. It starts with a bunch of arrows and backgrounds for the borders. and then it starts with a space, and then some special characters, numbers, and then letters, capitalized and lowercase. So let's compare this to an ASCII table and see how we're doing. Okay, let me see. So here we can see that the first character in an ASCII table is the space, and then comes all these characters, exclamation mark, etc. And then we get, pound and whatever, slash, and then we get so this follows the ASCII table basically perfectly. Then after the capital letters, that's the only difference that I'm seeing here, that these characters that come between Z, capital Z, and lowercase a, we seem to have a gap of 1, 2, 3, 4, 5, 6 characters. So there's a gap of 6 after the capital Z. That's the only thing that we really need to watch out for. And then the question mark spinning around, so the Z is the last one, because this is a special spinning animated character, I'm guessing. Okay, so I think I have enough information to start writing the font system. So yeah, let's get into it. So let's start by creating a class called font. And this needs to have, of course, the fonts. And it probably needs like a draw text method that takes in the text. It needs to know the graphics to draw it to, and it needs an X and a Y coordinate to know where to draw it. All right, and then we'll start by just looping across each character of the string. So we have like a text to char array, right? To char array, yep. Okay. So that's this, characters is, and then we can loop over those. I is less than characters dot length, I plus plus. All right. And then we can check, so the character C equals the characters at position I. And then if we have a new line, let's do that first, because that's easy, because then we don't have to draw anything. Because then all we got to do is update our X and Y position, so we probably need to keep track of where we are. So in screen X is X, screen Y is Y. And then here we can say like screen Y, we need to increment that by the font size. So let's keep, I think we're safe to hard code it because our graphics is not going to change. Static final int, I don't know, font size, whatever, it's 8. So we'll increment our Y position with font size, and then we'll reset X to go back. We'll reset screen X to go back to the original X. So this is a new line handled. All right, so now we need to know where in the file we need to be. So again, if we start to look at our ASCII table, we can see that character 32 is the space character. So here we got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 32 and then 10. So that means that 32 is space. Space is 10 in the sheet. Z between A has a gap of 6, we said. So that means that for the index, we can take the character C, because it has an integer value. It's a character, but it also has a integer value that is associated with it. So we can subtract 32 from it and then add 10, so that's 22. And then we need to check if we are at the lowercase characters. So can we do like character is lowercase? We need to skip those 6 characters that are not in our style sheet, sprite sheet. So we need to subtract, if we're lowercase, we need to subtract 6 from this value so that we get the correct index in our sprite sheet. All right, and then we can say graphics.drawImage fonts get index on our screen X and Y coordinate. And we can move our screen X with the font size. All right, it says here 4 can be replaced with enhanced 4. All right, fine, we'll do that. And I guess I'll inline this as well to make it nice. Okay, so let's test this one out. So let's go to the graphics file here and let's make an instance of our font. And then here we can say font is a new font with the loader.read font. We need to create that one. So let's create a method and let's move it to where we also do the man and the other tiles. So something with read man. Here, let's do read font. Font has a stream of 2 files, font 1 and font 2, we said. Let's double check. Font 1 and font 2. There we go. It should not be opaque. It should have transparent values. Okay, so this should read the font. So now the graphics can display some text, I presume. So let's just draw hello world, because we are programmers and programmers write hello world program. And let's do it at position 50-50, I guess. And we need to pass in the graphics. Okay, let's run the game and see if we get hello world. And there we have hello world. So I think what we can do now is give the heads up display a reference to this font class. So I think let's change the HUD to resemble this font structure a bit better. I don't want to pass in the resource loader anymore. I just want to pass in the images that the HUD needs for the borders. And let's pass in the font as well. Let's drop the resource loader here. Let's give this guy a reference to font. And then let's do this borders is the borders. And let's give the font as well. Okay, then we need to fix the graphics here to say create this font and then create the HUD with the font and loader.read border. I'm liking it a bit better this way because now the only class that does something with loading up graphics is the graphics class. So we keep it centralized at one point. Because I think that the font class will need a reference to the borders as well at some point, because we're going to draw some bordered text in like a nice text box. So yeah, we need to share some resources. Okay, so now the HUD can draw the score of Duke. So our score currently, of course, is 0. But we'll see if we can get that score to be a bit better. So let's go to the HUD again and let's find where we draw our score label. That's here. Score 3839 is the label. So let's just go down here and let's tell the font to draw some text. Now in the original game, should you look at a screenshot of Duke Nukem EGA, I guess I could just go to here. Let's make this full screen. So here we can see that the score is actually padded out. 1, 2, 3, 4, 5, 6, 7. It's eight zeros. So if we have a score of, let's say, 2,000 points, we need to pad zeros up front to it. So Java has a helper function for this. We can just use the string.format, where we want to format 8 zeros. So this %d will print a decimal value. So this is where our score should go. Okay, we don't keep track of the score just yet, but let me just say, like, we have this score here. It might be a bit too much. There we go. And then this 08 tells us to pad everything 8 times with an O. Okay, let's pass in the graphics and let's go for the X and Y values. That should be these. And let's run the game. And now we can see that we have hello world and our score displayed on the top right. So let's go to the game state and keep track of our score here. Level private int score. Let's initialize the score in the constructor. Select none. Let's say score starts out at 0. And then let's make a getter for the score. And then let's go back down to the HUD and let's go to game state get score. All right. So this should really give us a score of 0. All right, so now that we got that font stuff out of the way, I think for now displaying the score is good enough. We'll display the text boxes and stuff when we do the menus and the cutscenes and all that kind of stuff. So let's just remove our hello world text here. And I promised last time that we would fill out some of the gaps in the level. So it would be too much work to do that all right now because, we have to support all the enemies and the items and everything. So for today's episode, I thought I'd do the simple ones. We have a few gaps in the level that are just also background images that happen to be transparent. And for some reason, these are not located in the back tile sheets, but in the anim tile sheets. So let's go ahead and load up the anim tile sheets and figure out which ones it is that we will want to show. So the anim starts at 0 and goes all the way to 5. So there are quite a few animated objects in the game. So we got 2, 3, 4, and 5. And let's print out the sheet and let's call it anim.png. And then let's take a look at what we got. All right, so we got a lot of sprites here. So these we will tackle in a future episode, of course. But what we are interested in at the moment are some of the background tiles. So, for example, we got these things here. So here we got these brown spikes, which is just background material. These rocks and this little window, which happen to be some background material. And let's see. We got this fence here, which is a background sprite. And these 2 windows here, which are used in the first level. So what we'll do is we'll enhance our level rendering code to also take into account the animations. So let's first go to our resource loader and add a read method to just read in all the animation tiles as well. So we have that out of the way. So let's take this one as a start and then let's call it read anim. And then this starts, oh, I'm not doing this correct. So this starts at anim null, 0 I mean. And we got 1, 2, 3, 4, 5. 4, 3, 2, and 1. And we want it to be transparent. We do not want to limit to 48, I'm guessing. Okay, so this gives us all the animation tiles. Let's keep them here in our graphics class. Let's read them all in. Okay, and then now we can go to our level rendering code. And what we're doing here is resolving from a tile ID to a graphic to put onto the screen. So what we'll do is we'll extract this into a actual method, which will give us a graphic. So let's say buffered image tile is, I don't know, resolve tile with a tile ID. And then we can just resolve null, I think. So I think what we can just do is do this. Because draw image, if that gets null as the image, then this method does nothing. And that's what we want to do. So we can just resolve the tile and just give it null if we do not have a tile for the tile ID. So let's create a method. Private buffered image resolve tile ID. And let's put in our original tile ID like this. All right, so this should work. Okay, now we need to do a few things. So first off, let's just say like, okay, our image is null, and let's return it at the end. And then we can say like, if our tile ID is greater than 0, and if it's less than the 600 thing here, tile ID is less than 600, then we got a flasher here. So this means that our tile is going to be, let's see, tile set dot get tile ID divided by 32, and then add in our flasher offset. Image is that thing. Else, if our tile ID is larger than or equal to 0600, then we have just a regular old solid tile that's not that isn't supposed to be offsetted, and this goes all the way up to 3000. Tile ID less than 3000. Then this should be tile set get tile ID divided by 32 again. Else, and now we get to the special ones, and we should go to the Duke level format now to take a quick look at which ones we are looking at here. So what we said is something with brown spikes. So here we go. We have sprite number 11 in anim 4. So that's 4 times 48 plus 11. Is that sprite 203? Or is it 50? Yeah, I think it's 50 tiles per image. Yeah, so this should be sprite 211. So 211. So else if tile ID is exactly 3025, right? 3025. Yeah, that's the brown spikes. Then we'll return tile set image equals tile set get 211. And then we'll do the same for the left and the right rock and a little window, which are all situated next to each other. So that's 211, 212, 13, and 14. And then we had the fence. So let's look up the other decorative items. Here we go. Diamond-shaped wire mesh. So this is number 12 in anim 5. So that's 5 times 50 plus 12. So that should be 262. And that's 33D. So else if tile ID is the 3D one, image is tile set dot get 262, and then we have last two decorative items are the windows, so that's E and F, right next to the fence. So let's just E, F, and then that's 63. Nope. 63 and 64. Okay, so this should give us the simpler background tiles. So if we now run the game. Alright, so I think I messed up something here, because now some of the gaps in the level are filled up, but they are filled up with the wrong sprites. So let's see what I'm doing wrong here. So let's go to the resource loader, and are we reading in anim 0, 1, 2, 3, 4, and 5? So that is interesting. And then in the GFX class, I'm grabbing everything from the tile set. I should be grabbing those from the anim thing. That's what I'm doing wrong. So the tile set are just the background and the solid tiles. But these should be from anim, because that's where these sprites are located. So let's try again. Now reading in the correct sprites. So there we see the brown spikes. And here we got the window. So some gaps are filled up now. Not all of them, of course, but at least more and more of the level is starting to come together now. So I think that wraps it up for this episode. I did promise you to also include the ACME sign, but I think that deserves an episode onto itself, where we really start to work on the actor system of all the moving parts and all the interesting things in the level, such as items and enemies. So for now, I want to thank you very much for joining me. Join me next time, as we will start working on these actors and implementing those. But for now, if you have any questions, feel free to let me know in the comments below. If you like these series so far, please consider dropping a like and a subscribe, and I'll see you guys in the next episode. Laters.